So we're about to go over the Lent term test that both sets 1 and 2 pretty much took the same paper. With regard to our sets, some of you did well, some of you not so well. Okay. As always, I'm not going to sort of embarrass anybody and let everybody know each other's results. So if you want to know your exact result, email me and I will let you know. With one person to go, Ella hasn't taken the test as we speak. The average mark is about 50%. Ebbs, you did very well. You came top with 82%. Well done. Nina, you got 80. Well done. Josh, you got 75. Well done. So they were the top 3. Now, for the purposes of your Lent 2 grades, let me tell you the grade boundaries. So you needed 85% to get an A star, so nobody managed that. 75 an A, 65 an A minus, 55 a B plus, 45 a B, 35 a B minus, 25 a C plus. So you'll just have to play that video back if you want to go through those again. So I've used those the Lent 2 grades that you'll be getting over the next few days. I've used this test to to support the grades. Okay, so do go through your corrections carefully. Okay, hopefully you've all had an opportunity to run off the paper. I didn't want to burden all the other maths staff because I know lots of us aren't in at the moment. So hopefully you've had an opportunity to run off the paper. If not the end of the world. Just make notes as we go through the videos. Okay, and then you can just run it off at home and play the video again at home. They're all being uploaded onto YouTube. Question 1. So we've got a histogram and we've got to fill in the missing bars and we've got to fill in the one line missing in the table. So we start off by finding where we have the information in them both, and that's this bar here. So from 20 to 25 we know this area has to be 24, and this is the bar here. So it's got a base of 5 and it's got a height of 48. I've just made one square equal to 1. So height of 48, a base of 5, multiply those together, you get 240 small squares, equating to 24 people. So we can see that to break the code, if you like, the number of people to the number of small squares you multiply by 10. So we've broken the code, so we can now start filling in the gaps. So for this first bar here, we've got a base of 10. A base of 10, just going from 10 to 20. The number of people is 38, so we've broken the code. We know we have to multiply that by 10. So this bar is going to have 380 small squares. It's got a base of 10, so that needs to have a height of 38. So there's the bar there. Here, with this third bar, we've got 63 people, so 630 small squares. A base of 15, 630 divided by 15 gives us a height of 42. And this final bar here, 24 people multiplied by 10, that's 240 small squares. Divide by a base length of 30 gives us a height of 8. And then finally we just have to fill in this gap here. So how many small squares have we got? Well, a base of 10, a height of 31, so that's 310 small squares. Sorry, that's an error there. That should say 310, let's just correct that. That should say 310, not 320. So 310 small squares. It's got a base of 10, so a height of 31. Question 2, so another histogram. So let's start off by working out all the various areas of the each of the bars, because remember the area equals the frequency. So base of 10 times a height of 3.1, area 31. Base of 20 times a height of 2.2, area 44, and so on. So base of 30, height of 0.9 gives us an area of 27. That's the whole of this area here. And a base of 60, height of 0.3, an area of 18. So our total area, so the total number of times taken by a phone call centre to answer incoming calls, total number of calls is 31, add 44, add 27, add 18, which forms my denominator. Now, how many of those calls were less than 40 seconds? So I've popped in my 40-second mark there. So I've got 3 areas that are less than 40. I've got the whole of this 31. I've got this 44 and I've got this little area here which has got a base of 10, a height of 0.9, so an area of 9. So the total of number of calls less than 40 seconds, 31 add 44 add 9, which is 84. Now the question asks us for the percentage of calls less than 40 seconds, so 84 out of 120 multiplied by 100 to turn it into a percent, that's 70%. Question 3, so it's quite straightforward quadratic equation to factorise as we've only got a single e squared. So our two magic numbers multiply to make the number on the end, the minus 24, yet add to be the coefficient of e, the minus 2. So what two numbers multiplied to make minus 24, yet at the same time add to be minus 2? That's 4 and minus 6. So this factorised is e plus 4, e minus 6, and that equals 0. So our two solutions, what makes this 0? First of all, e being minus 4 makes this first bracket 0, and e being 6 makes this second bracket 0. Now the question insisted that you factorise, so those of you who chose to ignore that and do it by either the quadratic formula or completing the square got 0 marks. Question 4, part A. So you might just better do this straight by inspection, so you might just be good enough that you can just play around with the possibilities and go straight to this final answer. And if you can, good for you, that's absolutely fine. Now for those of you who need a more sort of slow and steady approach, like I do, you'll need to get used to this process here. Because the problem is we've got this 2t squared. So, first things first, our two magic numbers have to be multiplied to be 6. Now, the 6 came about by being the 2 times the plus 3. 2 times plus 3 is 6. And yet, at the same time, our magic numbers have to add to be the minus 7, the coefficient of t. So, those magic numbers are minus 1 and minus 6. Because minus 1 times minus 6 is 6, yet minus 1 added with minus 6 is minus 7. Now I'm afraid you can't just go straight to your final answer. You've got to go through the laborious process of going from 3 terms to 4 terms. So we're just splitting this middle term here using our minus 1 and our minus 6. Doesn't matter which way round, but I've gone this way round. But just be careful, this is minus 6t and minus t being the minus 7t. Quite a few of you are just sort of forgetting one of these t's here. So that line there, we have just rewritten this as 4 terms rather than 3. This line here, we're just fully factorising the opening 2 terms. So if you fully factorise 2t squared minus 6t, you get 2t open bracket t minus 3 close bracket. And similarly, if you fully factorise this here, the minus t plus 3, you get minus 1 bracket t minus 3 close bracket. And notice how we've got this repeated bracket. Now maybe that you just have to fiddle around with the sign here in order to get that repeated bracket. So our final answer is then the 2 components that aren't presently in a bracket, so the 2t minus 1 and our repeated bracket. So our final answer is this. Now, it makes more sense when you look at the reverse process. If you were multiplying out this pair of brackets, you first of all did 2t times t to get the 2t squared, then the 2t times the minus 3 to get the minus 6t, then you move on to the minus 1. Minus 1 times t gives you minus t, and minus 1 times minus 3 gives you the plus 3, and then going the other way, you would then gather like terms, gather these two here to get this. Now 4 part B is just the difference between 2 squares, so you just have to be on the lookout for this. If you've got a square number, or a square term rather, and you're taking away a square term, then you can write the answer like this. So the first component, the first term in each bracket is the square root of the 4x squared, so that's the 2x, and the second term is the square root of the 1, which is 1, but one of them has to be a plus 1, one of them has to be a minus 1. So if you were to multiply out this pair of brackets, terms 2 and 3 cancel out because you get 4x squared minus 2x plus 2x minus 1, and the 2x and the minus 2x would cancel out. Now 4c is really just another one like 4a. So our two magic numbers multiply to be 12, being the 2 times the 6, yet add to be the minus 7, so that's minus 3 and minus 4. Break down the middle term, the minus 7x into a minus 3x and a minus 4x. Doesn't matter which way round. Fully factorise the opening 2 terms to get this. fully factorise terms 3 and 4 to get this, and then your final answer comprises the 2x minus 3 and the repeated bracket of x minus 2. Question 5. So I think it makes sense to use the quadratic formula here. You can see it's not going to factorise because you've got to give your answer to 2 decimal places. And whilst you could complete the square on this, it's obviously difficult because of the 11. So the quadratic formula is up in the corner, although I have I've lost the bottom bit, which obviously should be 2a there. Right, so the quadratic formula is there. That is given. It's given in your IGCSE. You just copy it down from the front of the paper. And remember, a is the coefficient of the x squared, which is 11. B is the coefficient of x, which is the minus 3. And c is the minus 5. So you just plug this into the formula. Now your first line of workings must be to just literally display all of that. Now lots of you did not protect the minus 3. Minus 3 squared is plus 9. Lots and lots of you were forgetting to put the minus 3 in a bracket. So remember to protect the minus. So once you've done that, you are very welcome, as long as you've shown that line of workings, to use, if you've got one of those better calculators, to just use the buttons to be able to go straight to the solutions using the quadratic formula. So you're very welcome to go straight to these 2 solutions here. Obviously, if you're going to be using the formula, I would suggest you include this interim step just to help you gather your thoughts. So rounding these 2 to 2 decimal places, you get 0.82 and minus 0.55. Question 6. So given we need it in this format, we need to complete the square. So the key opening step, remember, you start off by halving the coefficient of x. So minus 8 is giving us minus 4. So our opening term is x minus 4 all squared. Now when you do x minus 4 all squared, so x minus 4 times x minus 4, you get x squared minus 8x plus 16. Now we just want the x squared minus 8x. We don't want the plus 16. So we need to minus the 16 in order to make this bit here exactly equal to that bit there. Okay, so just be clear in your mind. X minus 4 all squared gives you x squared minus 8x plus 16. So with this minus 16, we've got this bit here. And then obviously we mustn't forget the plus 19. So there's our plus 19. And then our second line is, our final answer is just to gather up these 2 bits here, giving us x minus 4 all squared plus 3. That's putting it into this format. Now, part B, write down the coordinates of the turning point. Now, a number of you were just forgetting that one of the benefits of completing the square is very easy to just find the turning point. Now, the turning point is where the y coordinates is maximized or minimized. Okay, so the turning point is the maximum or the minimum. We want to make y as small as possible. I think I said maximized a minute ago. I mean minimized. We need to make y as small as possible. So how do we make this as small as possible? Well, this term here has to be 0. When you square something, the smallest it can ever be is 0. So how do we make this term here 0? That is when x is plus 4. Now when x is plus 4, what y value do we get? Well, this term is 0. We then add 3 to it, giving us 3. So our turning point, our minimum point of this quadratic, is 4, 3. Question 7, so very similar part A to question 6. We need to complete the square, so we start off by halving the coefficient of the x, so the 6 becomes 3. Now x plus 3 all squared is x squared plus 6x plus 9. We don't want the plus 9, so we back that out with this minus 9 here. Okay, so again, make sure you're very clear. X plus 3 all squared minus 9 is equal to x squared plus 6x. Because we've got x squared plus 6x plus 9 minus 9. And then don't forget the plus 7. So we bring down the plus 7. And then we gather together these 2 terms to give us the minus 2. Now, Another benefit of completing the square, another thing it can do, as an equation, it is very easy to solve it once you have got the left-hand side into completing the square format. So our x squared plus 6x plus 7 is just this, clearly. So that can be replaced with this. So we just need to unpack this. So we add 2 to both sides to get this line. We then square root both sides, and that is the bit that then gives us the plus and minus option. Okay, the square root of 2 is plus or minus 2, so x plus 3 equals plus or minus the square root of 2. Then take away 3 from both sides, so we get x equaling minus 3 plus or minus the square root of 2. Question 8, multiplying out 3 brackets. So your first step is just to multiply out 2 brackets just as per normal. Doesn't matter which 2, I tend to do the second one and the third one. So I've just done that as a side working. I mean, some of you could probably do it in your head, but as a side working, x times minus 5, 3 times x, 3 times minus 5 gives us this here. So x plus 3 times x minus 5 is x squared minus 2x minus 15. So that's what this bit is here. So I now take my 2x minus 1 and I multiply it by this x squared minus 2x minus 15. Okay, so I'm just taking my 2x minus 1 and multiplying that by what I got when I multiplied these 2 brackets together. So again, lots of clause. So 2x times x squared, 2x cubed, 2x times minus 2x minus 4x squared, 2x times minus 15 is minus 30x. Then moving on to the minus 1, minus x squared plus 2x plus 15. And then finally gather up like terms. So we can gather up our 4x squared and our minus x squared to get minus 5x squared, minus 4x squared, minus x squared, minus 5x squared. Gather up our x's. So minus 30x plus 2x gives us minus 28x. And then we've got our plus 15. Question number 9, so find f of 11. Well, that's just what we get when we input 11 into the f function. So 2 lots of 11 divided by 11 minus 1, 22 over 10, which is 2.2. Now, for part B, state which value of x must be excluded from any domain of f. So really, what you've got to say to yourself is what values of x would be such that this function would not be able to process it. Now, you cannot divide by 0. If you just tried on your calculator, anything divided by 0, it just cannot be done. So this will not be valid where the denominator is 0, so that's when x equals 1. Now, part C, to find the inverse function, we need to change the subject. So you start off by choosing to let y equal the function, and then you're going to go through the algebraic process to make x the subject. So let's get it onto one level. Let's kick off by multiplying both sides by x minus 1. And then I've multiplied out that bracket, giving me this line here. Now the next step is to get all the terms with x in them on one side and all the terms that don't have x on them on the other. So I'm going to gather all my terms with x's to the left. So I've taken away 2x from both sides. And all the terms without x, so my minus y, I'm going to gather my y's on the right, so I'm choosing to add y to both sides. So just check, you can see how we've gone from this line to this line. We've taken away 2x and added y to both sides. Now that I've got all my terms on the left have all got x in them, I can factorize the left-hand side. So x open bracket y minus 2 close bracket equals y. Now for the first time now I've just got x cropping up once in the equation. Before then this is twice on every line. So nearly there now, so just divide both sides by y minus 2 and we get x equaling y over y minus 2. Now remember, y is just something we've artificially introduced to allow us to change the subject. So for our final answer, our inverse function of x, rather than being y over y minus 2, becomes x over x minus 2. Now remember what this machine does, this function does, it undoes whatever this machine does. So if you just want to double check, just take any x value you like and pop it into this machine and see what output you get, and then do this the other way around. Put that output into this machine and check you get back to your starting point up here. Question 10, part A. So be careful that you don't launch into trying to solve this. We're just being asked to show that this isn't the case in this situation, in this question. So this really has got to be our where we end up, not where we start. So what have we actually got here? We've got a trapezium and area. So this is an area of a trapezium problem. So how do you work out the area of a trapezium? You average the parallel sides and multiply that by the distance between the parallel sides. So we've got to average our x and our x plus 7. So to average those, we add them together and divide by 2. And then once we've done that, we're going to multiply by the this distance here, the 2x, and that gives us an area of 17. Too many of you are not reading the question. Lots of you were not bringing that 17 into the question. Okay, so it equals 17. So we've now just got to algebraically process this. So I've chosen to obviously simplify my numerator, so 2x plus 7, and then after that I've decided to multiply both sides by 2 in order to undo this dividing by 2. So I'm left with 2x plus 7 times the 2x equaling 2 lots of 17, the 34. I've then done the claw, so 2x times 2x is 4x squared, and 2x times 7 is plus 14x. Then taken away 34 from both sides to make it equal to 0. Then dividing through by 2, I do indeed get 2x squared plus 7x minus 17 equaling 0. Part B, so we're now just going to go through the algebraic process of solving this quadratic equation, but have a care. All right, we're being asked to work out the value singular of x. Now, why is that? Well, because x is a distance. So you've got to make sure when you've worked through the algebraic process, you reject the minus value that you get and make it clear that only this one, the positive value, is applicable, because obviously distances have to be positive. So a is 2, b is 7, c is minus 17. Popping that into the quadratic formula, we get these two solutions, and take the appropriate one to 3 significant figures is 1.65. Question 11. Now this should have been very straightforward, but too many of you are being sloppy. Too many of you are using the radius being 18.6, and too many of you aren't thinking. Clearly the volume of this is going to be half the volume of a sphere. Okay, so the volume of the sphere is given, it's 4/3 pi r cubed. Clearly the volume of this will be half of that, it will be 2/3 pi r cubed. So 2/3 times pi times the radius of 9.3 cubed gives us this. So to 3 significant figures, that is 1680. Question 12. Again, far too many of you being sloppy and not reading through the information. The question asks you to calculate the total surface area. Lots of you decided to work out the volume. So read the question and circle or highlight, underline the key words. So the surface area of this compound shape is going to be the surface area of the hemisphere, then the curved surface area of the cylindrical bit, and then of course the circle on the end. So be very clear in your mind that this has got 3 bits of surface area. Now the surface area of the hemisphere is obviously going to be half the surface area of a whole sphere. So half of 4 pi r squared is 2 pi r cubed. Is 2 pi r squared. The curved surface area of a cylinder, remember that's the circumference times the height of the cylindrical bit. So that's going to be the circumference, which is pi times the diameter. Okay, so pi times 6.8, not 3.4. And then the surface area of the circle, clearly that's just pi r squared. So substituting in the appropriate numbers, so the radius is 3.4, diameter is 6.8, height is 8.3, and so on, we get these 3 terms here. Again, work in pi. Far too many of you are just going straight to decimals. You can just do that translating right at the end. So my final answer is 2278 pi over 25, 286.261, so to 3 significant figures, that's 286. Question 13. So the key bit into this question is to pick up the volume of shape A equals the volume of shape B. So you're going to just work through and work out what the volume of shape A is, and then with shape B, where you don't know R, well, you can work it out because you know what the overall volume of shape B must be, because it's got to be the same as shape A. So kicking off with shape A, so the volume of this comprises the volume of the hemisphere, so another 2 pi r cubed, and the volume of the cone, which again is just given in the formula sheet, is a third pi r squared h. So just popping in the appropriate values, so r is 36, h is 53. Just be careful that whether it's one of those ones you have to use Pythagoras or not. For the volume of the cone, we're using h. H is the height straight up, which is fortunately the one we've been given on this occasion. So there was no need to do some Pythagoras to move between h and l. So anyway, processing that, we get 54,000 pi. And again, like I said earlier on, just leave it in terms of pi, okay? You can either deal with that right at the end, or like in this case, the pi's will cancel later on. So the volume of shape A is 54,000 pi. So moving on to the volume of shape B, a cylinder. So the volume of this is just going to be the area of the circle times the height. So pi r squared times h. Because remember, the volume of any prism is just the area of the cross section, the area of the end bit, multiplied by the depth of the prism. So pi r squared, because it's a circle, times the height. And the height is 2r. So multiplying through, pi times r squared times 2r is 2 pi r cubed. So we know the volume of shape B is 2 pi r cubed, but it equals the volume of shape A, which was the 54,000 pi. So 2 pi r cubed equals 54,000 pi. Now the pi's cancel, and then if we divide through by 2, we get 27,000 equaling r cubed. Cube root this, we get r being 30. Now just be careful you answer the question. The question asks us to calculate the height of shape B, which is 2 lots of r, so 2 lots of 30 being 60. Question 14. So find the value of A such that f of A equals 13. Now be very careful. Far too many of you weren't thinking and we're answering the question as if it said find f of 13. It is not. This question is asking us what value would you pop into the function in order that the output became 13. So you've really got to solve 2x plus 5 equaling 13. So take away 5 from both sides, divide by 2, and the input that would give you an output of 13 is A being 4. Now for part B, be careful you get this the right way around. 3 goes into the f function, and that output then goes into the g function. So 3 into the f function gives me 11. Taking that 11, putting that into the g function, by squaring the 11 and taking away 25, I get 96. Now part B2, you've got to pop the F machine into the G machine and set that equal to 0. So make sure you get that the right way around. It's the F machine into the G machine. So my F machine is 2x plus 5. Pop that into the G function, so it's 2x plus 5 all squared minus 25. So process that. 2x plus 5 all squared is 2x plus 5 times 2x plus 5, which is 4x squared plus 20x plus 25, and then take away the 25. So these 25s cancel, giving us 4x squared plus 20x. Now this g f of x has got to equal 0. So we now set this to equaling 0. Fully factorize, so 4x x plus 5 equals 0. So our two solutions are either x being 0 or x being minus 5.